Absolute errors. Right, in that absolute error, here absolute error like a defect in the measurement. So anything which you are measuring, if there is a small error in the measurement, suppose if you are measuring that anything, any substance you have given for you have measured it 5 times, okay, 5 times, then so how to calculate that value? Then actually absolute error is denoted with the delta A. Okay, it is always positive value measured. For example, you measured a quantity 5 times, then I can say it as first reading as a A1, A2, A3, A4, A5, like that, and so on. Suppose there is a delta A1. If I want to calculate defect in the first reading, how to calculate A mean? First I have to calculate average value of all the, like I have to add all the 5 values and divide it by 5. If I do, I'll get a mean value. So if I want to check what is the imperfectness in the first reading, I have to calculate delta A1. So delta A1, if I want to calculate, delta A1 is equal to first reading minus mean of the all 5 readings. I have to subtract from the A mean value. Similarly, for the second reading, delta A2, if I want to calculate, A2 minus A mean, average of all the 5 values. If I want to calculate delta A3, same thing, A3 minus A mean. Delta delta A4, if I want to calculate, A4 minus A mean value. If I want to calculate delta A5 value, then A5 minus average of all the 5 readings, like that. Then relative error. So relative error is generally it is a ratio of absolute error to the mean value of quantity measured. It is a ratio of absolute error to mean value. Absolute error, it is denoted with the delta A, right? So delta A mean divided by A mean value. Relative error is measured value. So whatever you are measuring, that is delta A mean, right? So mean value of the reading. A mean is 5 times. How much you measured a quantity? You measured 5 times. So that is A mean value. But delta A mean value is measured value. How many times you have measured? 5 times you have measured. That number you have to substitute below, and how many readings you have taken, that readings you have to add all the readings. Delta A mean means delta A1, delta A2, delta A3, delta A4, delta A5, like that. You have to add all the readings, that as a delta A mean. And how many times you have measured? 5 times you have measured. So that number you have to substitute below. Then you will get relative error. So mean, absolute error. How to find out mean absolute error? So we have a formula: delta A1 plus delta A2 plus delta A3 plus delta A4 plus delta A5 by 5. That is for the 5 reading. If I take number of readings, like n number of delta A values I have measured, then mean AE is equal to delta A1 plus delta A2 plus delta A3 and so on up to delta AN divided by N. Understood? Then coming for percentage error. Percentage error is relative error in terms of percentage. Whatever the relative error is there, that in terms of percentage I have to measure. So whatever the formula is, delta A mean divided by A mean. Whatever this measured value by how many times you are measuring, that you have to substitute and you have to multiply with 100. So you will get the value in percentage. So that is percentage error. Relative error you are measuring in terms of percentage. So percentage error is equal to delta A mean divided by A mean into 100. Usually it is denoted with delta A. To understand this percentage error and absolute error and relative error, just take one example. Suppose in successive measurements of period of oscillation of pendulum, the readings turn out to be 2.63863 seconds, 2.56 seconds, 2.42 seconds, 2.71 seconds and 2.80 seconds. Calculate the absolute error, relative error and percentage error. So now what I need to do, I need to calculate absolute error, relative error and as well as percentage error. So absolute error denoted with delta A, right? So how many readings I have taken here? 5 readings. So first I have to go for a mean value, average value. So I have to add all these 5 readings and by 5 I have to do. So 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80 by 5. If I do so, I'll get a mean value as a 2.62 seconds. That is the average value for all the 5 readings. Absolute error I have to calculate, right? So now I got a mean value. First reading A1 value is how much? 2.63. So 2.63 is the A1 value and 2.62 is the mean value. So delta A1 is equal to A1 minus A mean. A1 is how much? 2.63. A mean is how much? 2.62. So 0.01 second. Delta A1 value is 0.01 second. Delta A2 is equal to what? A2 minus A1. A2 minus A mean. A mean is how much? 2.62. But second reading is how much? 2.56. So 2.56 minus 2.62. You'll get 0.06 seconds. Right. Similarly, delta A3 minus A mean, 2.42 minus 2.62, 0.20 seconds. Delta A4 is equal to A4 minus A mean is equal to 2.71 minus 2.62, 0.09 seconds. Delta A5 is equal to A5 minus A mean, that is equal to 2.80 minus 2.62, 0.18 seconds. See here only I am not considering minus sign or positive sign. Why? Because just magnitude I am taking. Magnitude of delta A1, magnitude of delta A2, magnitude of delta A3, magnitude of delta A4 and magnitude of delta A5. So I am not taking sign. I am not considering signs here. So relative error formula is what? Delta A mean by A mean. So delta A mean, if I want to calculate, I have to add all these readings. 0.01 plus 0.06, 0.20 plus 0.09 plus 0.18 by how many readings? 5 readings. If I do so, I'll get delta A mean is equal to 0.11 seconds. So this is about delta A mean, but relative error is equal to what? Delta A mean by A mean. So delta A mean how much? 0.11 by A mean is how much? 2.62. If I do so, I'll get 0.04. That is relative error. But percentage error formula is relative error into 100. So 0.04 into 100. If I do so, I'll get 4%. So this is about how to calculate absolute error, relative error and percentage error. Next, in the next class, we will learn about combination of errors. Thank you.